Hello and welcome to our lesson on radicals, square roots, a more advanced look. First, let's talk some definitions. The value of a number, or it could be a variable, that when you multiply it 2 times in a row will equal the radicand. The index is right here, and that tells us the 2 times in a row bit because they're asking us for a square root. So what number 2 times in a row multiplied? The radicand goes underneath this funky check mark, and that's the radical sign. So we would say that we need to find the square root, sometimes referred to as the second root, of the number 64. Because we've got 64 here, we're looking for the square root. In other words, how many pairs can we pull out of the number 64? So, much like when we have to find the simplest form of a radical, we also need to do a factor tree for this as well. You can break this down however you want with whatever numbers you want. As long as they go in evenly, it's going to work out the same in the end. You're going to get down to the same prime numbers. For here, just because this is an even number, I know that 2 is going to go into there, and it's going to go into there 32 times. Once I find a prime number, I always put a dot underneath it so that I can keep track of all my prime numbers. 32 is not prime. I can break it down by 4 and 8. 4 is not prime, so I have to break down a little bit more. Now I have the primes of 2. 8's still not prime, so 2, and then 4. And 4 is not prime yet, so let's break it down one more time. We have 2 and 2. So we've got 1, 2, 3, 4, 5, 6 2's in a row. If we multiply all of them together, it should get us back up to 64. So if we're going to take it out of the radical sign now, pairs go out because we're looking for the square root. Singles have to stay in. So when we prime factored this, we got all of these numbers here. Now, there are 3 groups, doubles of 2's. We've got 1, 2, and 3 groups of 2. So they all come out, and there's nothing left over, so nothing stays under the radical sign. So you would multiply the groups of 2 together, and it would look like this. You've got one group of 2, you've got another group of 2, and that third group of 2. When you pull them out, you only pull them out and write them once to indicate it's a group of that number. So here's what it would look like if you're going to try to write out the final answer. There's your 8, and that was the 2 times 2 times 2. Notice there's absolutely nothing inside here because we didn't have any guys left over, so we don't have to do that. And if you don't have anything left over under the radical sign, you don't have to write the radical sign at all. So your final answer would just be written as the number 8. Now, you do know you have to double check. You always should double check your work in math. The new whole number that's outside of the radical sign, that 8 that we say, would have to be multiplied by itself the number of times that the index says, which is 2. Then you multiply whatever that answer is by whatever is underneath the radicand. With our example right now, there's nothing under the radicand to multiply, so we wouldn't have to do that. Now, if you've done all this correctly, the number that you come up with should match your original radicand that you were trying to solve for. So let's give it a try. We're going to multiply the whole number 8, the one that's outside, the number of times in the index. So we're taking the number 8 and we're multiplying it twice. 1, 2, because that's what the index says. 8 times 8 is 64. So now we're going to take that answer and multiply it by whatever is under the radicand. There's nothing there, so we don't have to multiply by anything. So this answer of 64 should match our original radicand. And let's go back and take a look. We had 64 was the number we were trying to break down, so that is correct. So how we broke it down to equal the answer 8 matches when you double check, so that means our answer is correct. Alright, let's try some more. We've got 108. Notice that the index is not written, so it's assumed to be 2, so we're looking for square roots or pairs. Let's break down 108. Again, because it's an even number, I know that 2 goes in there, and 2 goes in there 54 times. 2 is prime, 54 is not, so 6 times 9, 6 is not prime. 2 times 3, those are both prime numbers. And then 9's not prime, so let's break them down some more. Now we have all prime numbers. And remember that the index is 2, so we're looking for pairs. So I have a pair of 2's, and I also have a pair of 3's, and then I have one lonely little guy left over. So that means that I'm going to take out my pair of 2's and my pair of 3's, and remember they get multiplied, and the leftover is 3. He goes back underneath the radical sign. So once I simplify all this, I'm going to end up with 6 radical 3. Now your double check said take the number on the outside and multiply it by itself the number of times of the index. So we're actually doing 6 times 6, which is 36. And then we're going to take 36 and multiply it by whatever was under the radicand, or inside the radical sign, and that's going to get you back up to 108. So that means that this answer is correct. So let's try the second one now. We're going to take 54, and again, because we have an index of 2, we're looking for pairs. So let's prime factor. 54 broken down is 6 times 9. Neither one of them are primes, so we've got to keep going. 2 times 3, now we hit primes. And 3 times 3, so we have primes. Again, we're looking for pairs, and I see that we have a pair of 3s, but then these guys don't have a pair. So they don't go back outside of the radical, they stay inside the radical. The pairs go out. So I have a pair of 3s, and inside the radical I have 2 times the other lonely little single guy, which really means our answer is 2 radical 6. And you would do your double check. You're going to multiply your outside number, which is 3, the number of times in a row that the index tells you, so you're going to take 3 2 times in a row, which is 9, and then you're going to multiply it by whatever is under the radicand, which is 6, whatever is under the radical sign, and that's going to give you 54. And that matches the original one we were looking for. So that means that this answer right here, 3 radical 6, is correct. How about 24? If we break 24 down, you've got several different ways. You can do 2 times 12, 3 times 8, 6 times 4. Doesn't matter what you pick, all of them are going to end up to the same prime numbers in the end. So randomly, let's do 3 times 8. 3 is a prime, 8's not. Then I have a prime of 2, and then times 4, not prime. And then 2 is prime, and another 2 is prime. Remember, your index is 2, we're looking for pairs. So I have a pair of 2's, and then 2 lonely guys with nobody. So the lonely guys go back into the radical sign, and the pairs come out. So you have 2 radical, and remember you multiply them together, 6. So your double check says 2 times in a row, because that's your index. So 2 times 2 is 4. And then you take your answer 4 and you multiply it by whatever's left under the radical sign. So that's 4 times 6, and that's 24, and that was our original number, so that means that our answer right here is correct. Let's try the next one. Now we have 64. And 64, I know it's a perfect square, but let's try it. Let's say you didn't know that. We know it's even, so we can break it into 2, so that would be 32. And then you break it again. Let's see, we can go in 16 times. And then 16 is 2 times 8. And 8 is 2 times 4. And then 2 times 2. So I've got all these primes. Remember, the index is 2, so I'm looking for pairs. So I have 1, 2, 3 pairs of 2's. So that means I'm going to have 1 pair, 2 pair, 3 pair, and that equals 8. Nobody's left over, nobody's single, so this is your final answer. Now, if you're really smart and you spotted that right away, you know that 64 is a perfect square. So the square root of 64 is 8, and that's why. We just proved it. All right, how does this work in algebra? Now we're going to throw in an exponent with a variable. It's still going to work the same way with the coefficient. So 108, we're going to break him. Let's do 2 and 54, and then we're going to keep going. 9 and 6, 3 and 3, 3 and 2. So I've got all these prime numbers. Now, I have x cubed, which means that exponent tells you how many times in a row you're going to write the variable. I have 3 x's, so I'm going to write them 3 times in a row. And I'm looking for an index of 2. It's not written, so it's assumed to be 2. I have a pair of x's. Then I have a pair of 3's. And I also have a pair of 2's. So I got quite a few pairs coming out. I've got a pair of 2's times a pair of 3's times a pair of x's. And then I have a lonely 3 left and a lonely x. So they have to go back underneath, multiplied together under the radical. If we go ahead and simplify everything out, you end up with 6x radical 3x. Double checking works the same way. 6 2 times in a row, because your index is 2, so 6 times 6 is 36. X 2 times in a row is x squared. And then we have to multiply that by our radicand, which is 3x. So 36 times 3 is going to get you back to 108. And x squared times x We don't multiply them. Remember, we add exponents, so that gives us 3, and it gets us right back to the original. So here is our final answer, and it is correct. 6x radical 3x. Last one. We've got 54y to the 9th. So let's take 54 and break him. And 9 and 6, 3 and 3. So we've got all our primes, and then we've got another 3 times 2. Now y to the 9th, that means that we need to write the variable y 9 times. And yes, you absolutely should write them out, all full 9 of them, so that you don't accidentally forget one and drop one off, and then your answer wouldn't be correct. So if we're looking for indexes 2, pairs, I have a pair of 3's, and then these guys can't pair up, so they're lonely leftovers. So I'm looking to pair up my y's as well. I have 1, 2, 3, 4 pairs of y's, and a lonely leftover. So the pairs come out, pair of 3's, and then I had 1, 2, 3, 4 pairs of y's. So the number of pairs I have becomes the new exponent on the variable. And then the lonely guys, which are 6y, go back under radical signs. If I take 3 and square it, that's 9, and 9 times 6 is 54. If I take y to the 4th twice, that's 8, and then one more is 9. It gets me right back up there again. So this answer is correct. Now, we've got 24. Let's do 2 times 12. There's a prime. 2 times 6, got another prime, and 2 times 3. And then we've got z to the 16th. Oh goody, let's write it 16 times. 1, 2, 3, 4. If you don't do that, you're going to end up dropping one, you're going to forget one, and it's going to throw your answer off completely. So I've got 4 of these guys, 8, and I've got 12, and 4 more will make 16. After a while, when you get used to doing this, you can just see the number of pairs, but right now be sure to write it out so that your answer is correct. Again, the index is 2, so I'm looking for pairs. I have a pair of 2's. 1 pair is z, 2 pair, 3, 4, 5, 6, 7, 8 pairs of z's. So here's my 2's. They come out. Then I've got 8 pairs of z's, which means 8 is going to be my new exponent. And I do have 2 lonely non-paired guys, so they go back in, multiplied together, which would be 6. So you're going to square 2, which is 4, times 6 is 24, gets you back up there. 8 2 times is 16, and then we don't have any more under there, and that's correct, it was 16. This is our correct answer. Alright, here's the last one on the page. 64. Now if you remember, 64 is a perfect square. It's 8, so let's just go ahead and take them out now. However, you've got 10 m's. So we have to see how many pairs we can pull out if we have 10 of these guys listed all in a row. So we've got 1 pair, 2 pair, 3 pair, 4 pair, and 5 pair. If you're noticing a pattern here, notice how I had 10 of them, and I pulled them out in pairs, and I ended up with 5 pairs. So it turns out that when you're trying to find the square root of a radical sign, or a square root of an exponent, you just take the exponent and divide it by the index, and you'll get your answer. So it's 10 divided by 2. So you have 5 pairs. Double check, square 8, 64, multiply 5 twice, because you have 5 groups of them, and you get back to 10. This is your final answer. There was no leftovers, so nobody has to go back under the radical sign. A quick review, in order to find a square root of a radical expression, first, make that factor tree. All the prime numbers that can be doubled up, because we're looking for squares, need to be taken out of the radical sign. Any remaining singles, the ones that couldn't create a double, need to go back under the radical sign, and they're all multiplied together to create your brand new radicand. It works the same way for your exponents as well. Pull them out in pairs. Anyone not paired up goes back underneath. And be sure to go back and double check your answer like we did every time here too. That's it for our lesson on radical square roots, a more advanced look.